Course 3, Lesson 114. In this lesson, we are taking another look at basically surface area and calculating that area as a sweep, like you would sweep with a broom. We're having that same concept in this lesson. So if you just had a standard push broom and you found the area of what you just swept on a floor, we would take the width of the broom times the distance that you push it. That would tell you how much area you just swept on the floor. That's if our area was just a regular rectangle. But we can also do this with a lot of other types of sweeps as well. For example, if you had that broom that was a certain length, but kept one part of it staying the same, like right here, and swept an arc with that broom, we can still find the area by doing this kind of formula. We would take the width of the broom, which is represented with this side of our sweeping pattern, and multiply it by the average or the mean distance that the broom is pushed. And we find that by taking how much this point is pushed, which in this case is 0, and take how far this arc is, which we can find if we had more information, and average them. So take them, add them up, divide by 2. This seems like kind of an odd way to go about it, but it's a good way to start thinking about surface area in different ways. So let's put it actually into some practice. For example, what if you took a broom, and let's say here's our little broom, and we push it with this center point fixed all the way around the circle. All the way around. Well, let's answer some questions about this idea. How wide is the broom? CA? Well, we're saying that the broom is 5 centimeters long. That's the width of that broom. How far does point A move in one full turn? Well, point A is not fixed. We're going all the way around. Well, that means we're actually looking for the circumference of this, which comes by doing pi times diameter, or in our case, diameter is 10 times pi. And we can leave it in terms of pi, or if you multiplied it out, we would get 31.4 centimeters. So A moves 31.4 centimeters. Point C, the center of the circle, is fixed. So it doesn't move at all. It actually moves 0 centimeters in this case. A few more questions about this same situation. So what is the average distance that the points from A to C move in one full turn? Well, that's averaging how much C moved with how much A moved all the way around here. So we're saying, well, A moved 10 pi centimeters and C moved 0 centimeters. We want the average, so we take those. Since there's two different amounts, we divide by 2. So we get 10 pi divided by 2, or 5 pi centimeters is the average that we turn. So how much area does the broom cover? Well, from our formula that we said earlier, we're going to take the width of the broom, so 5 centimeters, and multiply it that the average that it moves, which is 5 pi, which gives us 25 pi centimeters squared. Notice that if I were to just do the regular formula for an area of a circle, I would be doing pi r squared, which in this case is pi times 5 squared. So we do get the same area, 25 pi centimeters squared, proving that our formula that we had before, which is that average that the broom moves times the width of the broom, does actually give us the correct area. So we can do this with a lot of different shapes. For example, what if it's not just 2-dimensional like a circle? What if it's 3-dimensional like a cylinder, like the soup can? Well, we can think about that broom in a couple different ways in order to find lateral surface area of this can. Remember, lateral surface area doesn't take into account the bases of a figure. It only wants the area like the label of the soup can, that area that goes around. So one way to think about this is sweep with the circumference. What we're saying is the upper rim, so this part right here, is like our broom. It's a really weird circular broom. Okay, circular broom that has right in the center. That's kind of like our handle of the broom, and we are actually sweeping down the sides of this can. So if we were to find the lateral surface area, I would find the width of the broom, which in this case is a circle, times how far it moves, which is the height. So in this case, if I wanted the width of the broom, I would be doing the circumference of the can, which is 2 pi r, or pi times diameter. And then we multiply by how far it moves, which is this distance, we'll call it the height of it. And so I find my lateral surface area by doing 2 pi r times the height. So that's one way to think about it. Circular broom pushing down the height of the can. The other way to think about it for this cylinder is if I had a broom that was actually the height of this can, here's my broom, and I would go around the can like this, sweeping all the way around, which in this case means that the width of my broom is the height of this can, and I'm sweeping around it, so the distance that it moves is actually the circumference. So I'll say pi times diameter. Either way, we end up with lateral surface area coming in either of these two forms, which are the same, 2 pi r times the height, or pi times diameter times the height. It gives us the same circumference, either way that you look at it. All right, what if we had a cone? Well, we know that the volume of a cone is different. We know that to find the surface area of the cone is different than a regular cylinder. Let's think about it like a sweep. Well, like we've said before, if I have a broom, let's say this broom goes the slant height of this cone, here's my broom, and it goes around the cone. That would mean that A is staying in place while B is moving all the way around this cone. Well, to find the lateral surface area, I would take the width of the broom, so width of the broom, times the average distance. Well, in this case, if I were to put it in terms of an actual cone, that would mean the width of the broom is like the slant height, and the average distance, well, A moves zero amount, and B moves the circumference, and we would find the average of that by dividing by 2. So that's exactly what we have as far as this new surface area formula, by saying the length of AB, which is our slant height, times the average that it moves, which is 0 plus the circumference, divided by 2. So let's plug in some numbers for this actual cone here. So the diameter of the base is 2 inches and the slant height is 4. So the slant height is 4, so that's the length of AB. 4 times 0 plus the circumference. Well, our circumference comes by doing pi times diameter, which in this case is 2, and we're going to divide by 2 in this case. We get 4 times 2 pi divided by 2, so just pi. And if you would like to use 3.14, you would just do 4 times 3.14, and you would have your centimeters squared in either case. So this is how we would plug it in if we were thinking about surface area like a sweep. Width of the broom times the average that it moves. We can show this formula in a different way with actual letters representing what we're talking about and simplify it very nicely. So just like we said, we have the slant height times the average of our distance. Well, if we're talking about the cone, we're always going to be doing 0 plus the circumference divided by 2, which means we're just doing circumference divided by 2. We can represent that circumference by 2 pi r divided by 2 times the slant height s. But we can simplify this very nicely to say, you know what, my lateral surface area, its formula is actually pi times the radius times the slant height, which means that we can actually find the slant height, or the surface area, the lateral surface area, pretty easily. For example, with this one, find how many square inches of paper are used to make a paper party hat for these dimensions. We want the slant height to be 7 inches with our diameter of 6. We're going to use 22/7 for pi. So let's plug it into our lateral surface area formula. We're going to do pi times radius times slant height. So let's do that. Pi is 22/7. The radius is 3. I'm going to put 3/1 to keep them all as fractions. And our slant height is 7/1. We can do some simplification here, the 7s, and we get a lateral surface area of 66 inches squared, meaning I'm going to need at least 66 square inches for each party hat that I need to create. All right, let's do this cylinder. Just a couple more examples here. Let's do this cylinder, thinking about if I have the width of the broom being this height of my cylinder, and I'm going to sweep all the way around here. Then I'm going to do width of this cylinder, so 5 centimeters times the circumference, which is diameter times pi, so 10 times pi. This is a simple one. We get our lateral surface area as 50 pi centimeters squared. And I believe this is our last example here. So how long is the slant height of the cone? Well, if we go back to how we find our slant height, we're going to use a cross section, which is just a triangle, with a height of 12 and half of the diameter is 5. You can check this with the Pythagorean theorem, but this is actually a Pythagorean triple, 5, 12, 13. So what's the slant height? It is 13 centimeters. All right, if the slant height sweeps around the cone, so here's our broom, and it's going to sweep around the cone all the way around. What is the average distance it moves? Well, this top point is 0, and the bottom that it moves is the circumference, which comes from doing diameter times pi, so 10 pi. So what's the lateral surface area of the cone? Well, we need to do that average distance, so in this case, 0 plus 10 pi divided by 2 times the slant height, or the width of the broom, which is 13. Ends up that we do 13 times 5 pi, which gives me, I believe, 65 pi. And you can plug in 3.14 in order to get the exact, or not exact, but the decimal answer here. But we have 65 pi centimeters squared. Okay, you could have also used our formula that we looked at earlier, pi times radius times slant height, in order to get there. Well, I hope you understand surface area a little bit better in this new way of thinking of it as the sweep of a broom around a figure. I hope this video helps with your homework and for studying.